Hello everyone, welcome back to my YouTube channel. So today we're going to explore an important phenomenon in modern physics known as Compton scattering. This effect played a crucial role in proving the light behaves not only as a wave but also particle. Earlier, we have discussed the de Broglie hypothesis, experimental proof of de Broglie hypothesis, and today will be discuss about on Compton scattering. Myself, Anima Ghosh, Associate Professor of Physics from SR University, Warangal, India. So, when a high energy radiation such as X-ray strikes on a material, it interacts with electrons and get scattered. But interestingly, the scattered radiation has different wavelengths than the incident radiation. This change in wavelength cannot be explained using the classical physics or classical mechanics. So the explanation comes from quantum theory, where light is treated as a particle called photons. This discovery made by scientist H. Compton provided the strong evidence of particle nature of light. So in today's lecture, we'll be very briefly discuss the concept and the main features of the Compton effect, and the description box I'll be give the details derivation of it. So let's start. Before starting, just few things that we know that what is like photon energy. So photon energy very beginning that we know that that photon energy that E is equal to h now. Also we know the photon momentum that P is equal to h by lambda. This is from de Broglie hypothesis. This is from de Broglie hypothesis. So that this come in the picture because of the failure of classical waves to explain the scattering fully. So Compton scattering is the scattering of high energy photons like X-ray by free or loosely bound electrons, resulting an increase in wavelength of scattered photon. So Compton discovered that when X-ray of a sharply defined frequency. So what type of wave is this Compton discovery? Compton discovery is that when X-ray, so X-rays of sharply defined frequency is sharp. The incident on a material of low atomic number, like so it is applicable, or it should apply for the low atomic number, low atomic number like carbon. They suffered a change of frequency on scattering. So the scattered beam contain two type of wavelength. So which is the scattering beam? So see, scattered beam, it will be two type of wavelength. One is one wavelength that will exist with line of longer wavelength. So the change of wavelength is due to loss of energy of incident X-ray. This elastic interaction is known as Compton effect. So this is kind of elastic interaction. Now let us consider that with a diagram to understand the Compton scattering. So this is let's consider here that this is x-axis and this is y-axis. So now one incident photon of energy is equal to h nu. So this is incident photon. Incident photon, and then if interact here with a particle, then it will get a scattered photon. This is a scattered photon of energy, let's say E dash is equal to h nu dash, and the recoil atom is here. This is called the recoil electron. Sorry, and this angle is phi, and let's say this angle is theta. So here the incident, let's consider the situation that an incident photon with an energy E is equal to h nu and momentum hc by lambda strike an electron which is at rest over here. The initial momentum of the electron is 0 and its initial energy is only the rest mass energy, that and m naught c square. And the scattered photon having the energy E dash is equal to h nu dash and striking an angle with theta with the x-axis, and the recoil electron making an angle phi, and it is going, and so the energy of this recoil atom basically will be mc square. So according to if we apply that principle of conservation of energy, so we can get the from principle of conservation of energy that h nu plus m naught c square is equal to h nu dash plus m c square. And if we split it as x and y component of momentum and apply the principle of conservation of momentum, then we can get h nu divided by c is equal to h nu dash divided by c cos of theta plus mv cos of phi. This is equation number 2, and we can get 0 is equal to nu dash divided by c sin of theta minus mv sin of phi. This is equation number 3. So now if we just solve this equation 1, 2 and 3, in description box I will be add the details of this calculation to solve. So one can get lambda minus lambda dash, that is equal to h divided by m naught c 1 minus cos of theta. Or we can write as the change in wavelength is equal to d lambda, that is equal to h divided by m naught c 1 minus cos of theta. So these relations shows us that d lambda is independent of the wavelength of the incident radiations, and this as well as the nature of the scattering substance. So that delta lambda depends only, here we can see from the equation that depends only angle of the scattering angle. So if we now look at the case studies for with this, so let us write once again the formula, that is d lambda, that is equal to h divided by m naught c 1 minus cos of theta. So if you just discuss the case studies, case 1, that if we have the scattering angle theta that is equal to 0, then we can write cos theta that is equal to 1. So we can get d lambda is equal to 0. So in case 2, if we consider theta that equal to 90 degree, so we can get cos of theta is equal to 0. So we can get delta lambda is equal to h divided by m naught c. So just use that h is equal to, we know that h is equal to 6.63 into 10 power of minus 34 divided by 9 into 1 into 10 power of minus 31, and then 3 into 10 power of 8, that is equal to 0.0243 angstrom. So this is called as Compton wavelength. This is known as So now if we do the case 3, that when theta is equal to 180 degree, that means cos of theta is equal to minus 1. So with this we can find out delta lambda is equal to twice of, we can see this delta lambda is equal to twice of h naught, sorry, so we can find out, just let me write it again, that twice of h divided by m naught c, that is equal to 0.0485 angstrom. So if we conclude that for just what is the maximum wavelength of this Compton scattering, so the maximum wavelength we can achieve 0.48 at the value theta is equal to 180. So this is the basic fundamental concept and understanding of the Compton scattering. So today is up to this. In next, will we bring the details of about Compton scattering effect with more with the quantum mechanics. So please like the video, and thank you very much for watching this video lecture. Thank you.